Hello everyone, Luke here and welcome back to the channel. So in today's video what we're going to be doing is delving into compliant mechanisms. I think these are really cool, probably one of my favourite mechanisms, and we're going to touch a little bit on their history and I'm going to give you a few examples. So let's get into what is a compliant mechanism. Compliant mechanisms are a type of mechanism that rely on the flexibility and the elasticity of the materials to achieve the desired motions or functions without the need of a traditional rigid components or separate components. Instead, relying on the joints of hinges, compliant mechanisms utilize the inherent properties of the materials to deform and transmit forces. Or how Wikipedia would explain it, a compliant mechanism is a flexible mechanism that achieves force and motion transmission through an elastic body deformation. So I thought that was really interesting, so let's get into the history.
Arr, shiver me timbers.
The concept of compliant mechanisms dates back centuries, with early examples being found in ancient devices, well, like a bow and arrow. From the 17th century, scientists like Robert Hooke, who laid the foundation for understanding how materials deform under applied forces. However, it wasn't until the 20th century that engineers and researchers began formalising principles behind compliant mechanisms. Advancements in material science and manufacturing techniques made it possible to create practical compliant mechanisms. Researchers and engineers began to explore the design of these mechanisms, and it could possibly offer a simpler and more efficient design by replacing traditional, well, joints and bearings. In modern developments, researchers have developed systematic approaches to create and optimize compliant mechanisms, well, for specific applications. And this has led to a significant growth in the field with applications in robotics, aerospace, biomedical devices, and even, well, micro-electromechanical systems, or MEMS. So in my hands are two examples of compliant mechanisms. I think these are really cool, and like I stated at the beginning of the video, they rely on the flexibility and the elasticity of a material to achieve the desired motions or functions without relying on any separate components. So this is one whole body, and this is a clip right here. And like I said, it does what I desire it to do. I can clip it onto something and voila, I can let it go at the same time. But this one is my favorite. This is an elastic band shooter, and again, it's one whole body. It relies on the elasticity and the flexibility of the material. And if I aim this up lovely jubbly, I don't know if you saw that, but it flung the elastic band across the studio. Now that is quite fun. So depending on who you talk to or where you're looking at, there seems to be many advantages and many disadvantages to compliant mechanisms. But just by looking at these, I can see, well, one advantage and one disadvantage. And I suppose the advantage would be cost. Cost of production. This is one whole body, so you're not having to machine, print, manufacture a whole bunch of separate parts to combine into one thing that's going to work. This is one thing, and depending on what its function is, it is just going to work. So when it comes to the disadvantage, I suppose it's going to be a bit of a twofer. And I say that because it's a two for one. So the first thing, there isn't going to be a full range of motion. That means it's not going to be able to do a continuous motion like traditional, well, bearings or joints can do. And secondly, it's the strength of joints or the strength of the connections. I reckon that it probably wouldn't take too long before these little joints and connections will start to fatigue and maybe crack. But I suppose it all depends on the material too. But without actually looking and really researching into it, just by looking at these, that's the things that I can come up with.
Okay, I'll talk to you later. See you later. Bye.
So as some of you guys might know, I really enjoy mechanisms. I love looking into them, I love researching about them, and I enjoy looking into the history as well, because as some of you guys might know, my favourite saying is look backwards to look forwards, and I suppose that comes under the same category. But with that being said, that does bring me to the end of this video. I really hope you enjoyed it, and if you have any questions or suggestions, please don't hesitate to leave them in the comments, and I will try my best to answer them all. Anyway guys, I hope you have the most fantastic day, and I will see you later.